Next, let's see modes of timers. We know in 8051 we can have two timers T0 and T1. Each can operate or make to operate in four modes: mode 0, mode 1, mode 2 and mode 3. Let's see some details about these modes. So first one is mode 0. Mode 0 is a 13-bit time counter. 13-bit timer counter. In this mode, please note the clock to the counting stage. So the input to the counter is coming from here. So first of all, let's see the block diagram. So the clock is coming from that stage. So first of all, you need to mark clock. Then low order register, what the number to be loaded, that is TLX. Count, count is loaded in TL0 and TH0 in the case of timer 0, TL1 and TH1 in the case of timer 1. So here 5-bit is loaded. Why? Because we need in this mode it is operated as 13-bit counter. Clear? 13-bit timer bar counter. Okay. So next one is, so whenever this thing is get overflowed, that means a 5-bit, all 5-bit become 1. After that overflow will come. After overflow, what happens? It will change THX. Clear? THX. So it is an 8-bit. So totally 8 plus 5, 13-bit. So whenever this and this get overflowed, what happens? Overflow flag will set, that is TF. X we can call, X may be 0 or 1, 0 for timer 0 and 1 for timer 1. So whenever TF, that means timer overflow flag is setting, it will send interrupt, clear, interrupt signal. That means it will interrupt microprocessor and it will service interrupt service subroutine, that is ISR, related to this counting operation. So during this process, counting process, processor is free for doing other operation. So whenever TFX is becoming 1, it interrupt processor. That means it will processor will stop the main program and branches to ISR. While branching subroutine, that is ISR, this flag is getting clear in order to receive further interrupt signal, that is, or in order to get information about a pending interrupt, this flag is getting auto cleared. So this is the working. So clock is given from this stage. So from here clock is coming. After each clock, these low order 5 bits getting incremented. Whenever all these 5 bit become 1, overflow occurs, it will change THX. Whenever all these things become 1, overflow flag will, timer overflow will come. It will interrupt processor, service ISR. Clear? So on every clock pulse, lower byte is incremented, TLX. Whenever lower byte overflows, it increment higher byte. If higher byte also overflowed, it will set TFX is equal to 1. So what is the maximum count occurs by means of mode 0? How many bits are there? 13 bits. So maximum count is 2 raised to 13. This is maximum count. What is 2 raised to 13? 2 raised to 3 into 2 raised to 10. 2 raised to 3 is 8. 2 raised to 10 is 1k. So 8k. Clear? So when we are writing that in hexa, it will come like this. maximum counting, max count is 1 FF. When we are doing like this, so 0th bit 1 2 3 all the way up to 13 12, everything become 1, group of 4, and this 1. So this is 1, this is EF, this is EF, and this is EF. So the maximum count in hexa using mod 0 is 2 raised to 13, that is 1 FFH. Here, one thing to be noted is that here lower byte is 5 bit. It will overflow, that means lower byte will overflow exactly at 2 raised to 5. Clear? 2 raised to 5 means all the ones, all 5 ones become 1. After that, it will get overflow. Clear? When it become 5, 2 raised to 3 is 8 into 2 raised to 2, 8 into 4, 32. Counter will count based on clock. After 32 pulses, 32 clock pulses, we can obtain an increment over THX. Clear? So it will overflow after 2 raised to 5, that is 32 pulses. This mod is used, so after 32 we got only 1 pulse. After next 32 we can obtain another higher order clock. Clear? Higher order signal or clock. So this mod is used to divide the frequency, whatever frequency you are giving here, that is getting divided by 32. Clear? So after first 32 pulses we got overflow to TH. After next 32 pulses we can obtain another overflow. So in this way it is used to divide the given frequency by 32. So overflow to TH is, how we can find out that one? Overflow to TH is, TH like overflow endana? Total pulses. How many pulses are coming from clock? Total pulses divided by 32. So these all are about mod 0. Mod 0 is a 13-bit counter. We can count up to 1 FFF. So after each 32 pulses, we can obtain an overflow to TH, or in other words, it is used to divide the frequency by 32. Next one is mod 1. Mod 1 is most popular. It is a 16-bit counter. Entire 16-bit content, that is TL and THX, is used for counting, for loading count. So it is a 16-bit counter. Just like earlier, this is coming from clock stage. Clear? Clock stage. After each clock, TLX is getting incremented. Then whenever TLX is getting overflowed, what happens? It will increment THX. So this is 8-bit, this is also 8-bit. So totally we can have 16-bit number which is loaded in counter registers. So these two things are SFRs. So whenever both these registers getting overloaded, it will send what? An overflow flag, TEFX. Whenever TFX become 1, it will interrupt the main program or processor in general. So mod 1 gives biggest delay. It gives biggest delay. So maximum count is, what is maximum count? Here 16-bit data is saved in registers associated with the timers. So we can count up to 2 raised to 16, that is 64k, that is 64k counts are available, that is 65536 count is possible total. So this number is 65535, that is F. So including 0 we can have total count of 65536. Okay. So most preferred mode is mode 1 to produce delay. So for producing delay, first choice is mode 1. Please note this. While designing programming associated with the square wave generation and like programs, the most preferred mode is mode 1. If it is not mentioned, you need to use mode 1. Please remember that one. Next mode is mode 2. It is known as 8-bit timer bar counter with reload. It is the self-reloading mode. The moment its timer overflow occurs, at that time original count to be loaded in register is reloaded. So what happens? It will start counting again. So here, without the intention of the programmer, the process is repeated. Programmer once only need to load the required number in register. So in this mode, whatever be the operation to be done for a particular period, see after each duration, let's say 1 minute duration, after each 1 minute the process is repeated. So please note, if we need to send a missile exactly in 1 minute to a particular location or from a particular location only one times, which mode is preferred? Mode 1 is preferred. But if this missile process, suppose we need to send a missile every 1 minute, clear, in each 1 minute we need to send for a particular situation, depending on situation. So it may be for testing the process, testing the batch, clear. So in order to do that one, so for each interval we need to do this process. That means each 1 minute we need to send one missile. So under that condition, which mode is preferred? Mode 2 is preferred. Without running the program again and again, the best choice is mode 2. As the count is reloaded, it requires to backup. So count, see during count what is happening? Count is changing. So immediately after it is getting overloaded, whatever be the count is loaded earlier, that need to return back into the counter. So for that one backup is required. So the same number is loaded in TLX and THX during mode 2 operation. Clear? As the count is reloaded, it requires to backup somewhere. So some number, that means that number, the number corresponding to the count, the required count, need to be loaded in TLX and THX register. That means 2 copies of the count is loaded in TLX and THX. We can draw the logic diagram like this. This is the clock stage which is coming from earlier diagram, logic diagram. This is TLX. This is 8-bit. So same copy is also available in THX. The same number, whatever be the number loaded here, that is available here also. So whenever timer overflow occurs, that inform THX, and THX will reload the content of a copy. A copy of THX is going into TLX. Okay. So at the same time, this overflow, this indicate this is overflow. Whenever overflow occurs, it do two things. It will inform TH, means it will reload the content of THS, a copy of this one, into TLX, and what happens? It will timer overflow. It will set timer overflow, and it will interrupt. So after that delay, missile need to send clear. For example, so it will interrupt, do the service subroutine. While servicing, what happens? TF. So this is one of the importance of auto clearing. So after doing this operation, it need to clear. It need to clear. So whenever this condition again overflows, that is after this first overflow, what happens? THS is again loaded the required number corresponding to the count in TLX register, in order to inform whether this is overflowed in second condition. This should be, after servicing this interrupt, this should be clear. Then only this informs that I overflowed. In next stage also you need to send one more missile. Clear. So immediately after servicing ISR, it will clear TFX. So this is this signal is enable reload. Say the number loaded in TLX is 26. So same 26 is loaded here also. So after 26, 27, 28, 29, 22, etc. all the way up to FF. After FF, what happens? Overflow flag will come. Whenever this get overflow, automatically what is happening? The same count is reloaded by means of this enabled reload signal, and it will start to count from 26 again. So during this time, whenever it is interrupted processor, it will automatically clear. So after next overflow of TLX, again THS is loaded here. It will inform TFX as 1. It will make TFX to 1, and so on. This process is repeated. There is no stopping in this mode. Clear. So this mode is known as continuous mode. All other modes are single modes. Whenever counting over, they will stop. Single mode, if they are single mode, whenever count is over, they will stop. Here it will repeat the count. Here we can obtain repeated delay. The last mode in timer is mode 3. It is two 8-bit timers. Two 8-bit timers using T0. Two 8-bit timers using T0. Here timer 0 acts as two separate 8-bit timers. So we know totally we can have two timers. T1, it is 16-bit timer. T0 is also 16-bit timer. It is splitted into two 8-bit timers. TEH0 and TL0. This is 8-bit. This is also 8-bit. We know what is the overflow flag corresponding to T1. It is TF1. We know in the case of T0, overflow flag is TF0. So in this mode, the overflow flag to TL0 is TF0. Clear. Overflow flag of T0 is used as, so this acts as one timer, this acts as another timer. So whenever the TH0 over means whenever TH0 counter or timer is getting overflowed, it will overflow. The overflow signal is given through TF1. Whenever timer low order, that is TL0, is getting overflowed, the overflow flag of T0 is getting set. It will interrupt the processor. do ISR. While servicing ISR, TF0 and TF1 is auto clear. So it is to be noted that in serial communication during transmission between bits, some fixed delay is required. So during serial communication, bit by bit is sending serially. After sending, suppose I need to send 1001, clear. After this one, some gap is there, clear. After some gap, it will send first it will send 1, then it will send 0. After some delay, next 0 will send. After some delay, 1 is sending. Clear. Then start and stop thing is there that we will discuss if time permit during the discussion of serial communication, serial programming. Okay. So anyway, while sending this data serially, while transmitting these different bits, between bits some delay is required. So T1 is used to obtain that one. So under that kind of serial communication, T1 is the default timer for creating delay for serial communication. So it is not free, it is not available to us. So the default timer used during serial communication is timer 1 T1. So TF1 is not required for timer 1. So it is free. TF1 is free. So in this mode, we make use of TF1 as the overflow flag for TH0. Here we can have two independent timers, that is TL0, that is 8-bit, and TH0, 8-bit. So let's draw the logic diagram. In first case, the clock is coming from the earlier stage. After each clock, what happens? It will increment TL0, and TL0, once the TL0 is getting overflowed, timer overflow flag TF0 will set. It interrupt the processor. Clear? So this is from clock stage. This is also from clock stage. CLK, clock stage, from stage. This is also from clock stage. Mod 0 also from clock stage. Okay, this is the first counter which is available in this mod, two 8-bit counters using T0, that is low order, clear, low order 8-bit. Next one is here it is using internal clock only. Internal clock. What is internal clock? F crystal oscillator divided by 12. So that is internal clock frequency. So this is given to TH0. When TH0 overflow, that means for each clock TH0 is incremented. Whenever TH0 overflow, it will set TF1, and just like earlier, it will interrupt processor. It will interrupt processor. So in short, basically we can have two timers T0 and T1. In this mode, that is mode 3, we can have three timers TH0, TL0 and T1. All are connected with the internal clock, that is F oscillator divided by 12. So if we are using internal clocks, these timers will work as timers. That is, these TL0, TH0 and T1 will work as timer just for creating delay. So when we are considering this diagram, 8051 is having two pins, two external pins, T0 and T1. We can give external clock through this one. So T1 is the external clock input to timer 1, and this is the clock input to T0. Clear? This is T0. But T0, now in this mode, T0 L and T0H is there. So this clock is the clock, external clock to T0L only. So T0H is connected with only what? Internal clock. So T0H is connected with only internal clock. If internal clock is given to any timers or timer bar counters, it acts as timers. If both is given, depending on the requirement, we can make it as timer or counter. But in the case of T0 higher order, internal clock only connected with T0H, so it work only as timer.